Well, I'm back. I know I said I probably wouldn't do another video today, but I figure I might as well get some of this stuff out the door as well. I've been alluding to some of the findings I have on light, so this is a great way to kind of start talking about that. We've already talked about basically, pi, fine structure constant, golden ratio, um, gravity. These things all kind of emerge out of this behavior and interactions of this energy constant, and through the SyPi equation. Light is also involved. So how I want to show you that is basically mapping out this acceleration. I've tested it, to a billion on the positive side and a billion on the negative side to try to count how many orbits we get on the positive side versus the negative side. And that's what this shows. So we have a value n, which is either negative 1 billion through positive 1 billion, including the number 0. We use alpha as a function of SyPi, and basically this n here is the equivalent to c here. I'm going to have to start getting some of the naming of variables straight so that there's less confusion in some ways. But let's just follow along. So we're going to have O as the number of times that basically the cosine on this goes negative, which indicates an orbit. Okay, just the one time it goes, as soon as it goes negative, we're going to count that as a tick, and that's gonna be called an orbit. As you can see, when we're positive, there's only 2 orbits from 0 to a billion. Whereas on the negative side, there's 2,094 orbits from 0 to negative a billion. It works out to half when you divide 2,094 by 2. And if you get the ratio, the actual percentage, it works out to basically 99.9044% of the orbits occur on the negative side. Okay, so when n here is negative, then it holds 99.99 or 0.9044% of the orbits. I've alluded to light having a connection with bubbles. Now, light and bubbles are both lazy, as they call it, and whereas they look for the shortest possible path. 300 in degrees is opposite to 120, and bubbles always connect at 120 degrees. So if we take that information and we multiply this ratio as far as 99% of the orbits occurring on the negative side, we multiply that by 300 or 120, in this case 300, right, because it's the opposite, we get a number that is getting dangerously close to the measured speed of light. And I feel like if we expand the bounds to more than a billion, which I don't know the number yet, I feel like this number could converge on the speed of light. Of course, it's not in the same units right now, but the units is something that I've already described that I have to figure out. And in that, I will leave you with a question in looking at this set of bubbles down here with the light. I ask you what angle or what source, where's the source of light coming from? I did use a laser, but where is the source of light, or the source of the laser coming from in this picture? I would suggest that what we see as light could possibly be refracted or completely reflected, and we don't know. And when we measure that light, we're measuring from the refracted or reflected source. This is something that I've yet to confirm. It's just kind of a very loose theory based on a lot of the research that I have been doing, and I'm going to be releasing that stuff as I go along. So for now, I'll leave it at that. We've connected pi, the fine structure constant, the golden ratio, gravity, the speed of light, and what we call dark energy. Um, it's pretty fascinating stuff. Try it yourself. Don't take my word for it. I've got all the pages available for you to all test. Thank you.